Hello Year 11, here's your 5 a day, and here are your answers. Okay, so today we're going to be looking at finding angles between planes, and there'll also be some more 3D problems with trigonometry involved. So, if we consider a point that's on the common line of two planes, pi1 and pi2. So a plane is an infinite 2D surface. So if you think of a tabletop, but that it extends forever in all directions. If we have two intersecting planes, like we've got here, then there is a common line where they intersect. Like where two lines intersect, there is a single common point. Where two planes intersect, there is a common line. And here I've chosen a point on that line. If I draw lines PA and PB at right angles to this line, so PA is perpendicular to the common line on the plane pi1, and PB is perpendicular to the common line on the plane pi2. The angle APB is the angle between the planes pi1 and pi2. And if we say that if pi2 is horizontal, which obviously we can just always rotate it to make it horizontal, then PA is called the line of greatest slope in the plane pi1. So there will be an infinite number of lines of greatest slope. They will all be parallel to each other, and they will all be perpendicular to the common line. So have a look at this cuboid here. It's A, B, C, D, A dash, B dash, C dash, D dash. We need to find the angle between the planes ACD dash and DCD dash. Now, that probably sounds more complicated than it looks when I say it. So we need to identify where these planes are. So let's start with ACD dash. So if we draw a line from A to C to D dash and back to A again, you can see this triangle that's kind of cuts diagonally through the cuboid. That's part of my plane. The plane is infinite, but within the cuboid, that's where my plane is. Then if we have a look at the other part, if I do a different colour, so D, C, D dash, back to the beginning, looks like this. So that plane, D, C, D dash, is just the same as the plane that the top of the box is. So that one's easier to visualise. We can see that the common line between these two planes is here, C, D dash. So we're going to let M be the midpoint of that line segment. And if I just get rid of my scribbles, I can think about this triangle here, where phi is this angle that I'm trying to find. Now MD is perpendicular to CD dash in the plane DCD dash. So remember that plane is the one that's the top of the box. This is perpendicular. I know this is perpendicular because the base of my cuboid, and therefore the top of my cuboid, is a square, 3A, 3A. So I know that if M is the midpoint, the line MD is going to cut this isosceles triangle into two right-angled triangles. The line MA is perpendicular to the line CD dash in the plane ACD dash. That's that triangle that was diagonally cutting through the cuboid that I drew at the beginning. So phi, as I've labelled it here, is the angle between those planes, and that's what I'm looking for. So D to M is half of the distance D to C dash. I can use Pythagoras to find DC dash. That's just the square root of 3a all squared plus 3a all squared, which is 3a root 2. And then I'm multiplying that by a half because I only need to the middle of the cuboid, not all the way across. And so I know that this length, that's the one I just found up here, and I know this length. As I said in the previous lesson, this would be much better if I drew this out. That's phi that I'm trying to find. This is A, and this is as so. And so I've got opposite and I've got adjacent. So tan phi equals A divided by this dm. If I simplify this, the A's cancel. Should I show you how? Let's show you how I did that. So we've got A over 3A root 2 over 2. When I divide by a fraction, that's the same as multiplying by its reciprocal. So that's A times 2 over 3A root 2, 2A over 3A root 2. My A's cancel. I multiply by root 2 over root 2. So that gives me 2 root 2 over 6, which simplifies to root 2 over 3. And so phi is inverse tan of root 2 over 3, which you pop into your calculator and 2 decimal places, you get 25.24 degrees. If you're not told whether to give your answer in radians or degrees, then it's up to you. Okay, so from that you should be able to work your way through questions 1 to 14 now. Remember, draw a 2D triangle for each of your steps. For these ones, draw yourself the 3D shape as well to help you picture where all of the parts go. Make sure you mark your work as you go and let me know if you have any questions. Thank you.